highlighted portion, I want to highlight this part over here, this one, the green one. Can you see? Can you see? So
Yes, ma'am.
for stopping the water, they were using shapes and everything. Okay, the name of the shape was not known to them, but eventually they were making pyramid, they were making triangles. Okay, they were making this type of structure to just stop the water. Okay, later on in Egypt also, this type of pyramid already naturally existed in Egypt. Okay, and they were like when the revolution happened, day by day they started knowing, okay, this shape is called pyramid in mathematics. Here this is 3D shape. Okay, you can see I have drawn the pyramid, I have written the base of this pyramid is rectangle. Can you see? Can you
Yes,
see it,
ma'am.
Apurva? Okay, so
Yes,
day by
ma'am.
day they the shapes, okay, in a better way. Then the truncated pyramid was also known to them. Truncated pyramid means the broken part of the pyramid. Okay, so this truncated pyramid, they started finding the volume of this truncated pyramid. Okay, then revolution happened, and in this Harappa and Mohenjo-daro, this era, we have seen the buildings, the bricks, everything. They are so well planned. Here, 4:1, 2:1. This was the measurement of the bricks. Sometimes this also comes in exam, that what was the measurement of brick in Harappa and Mohenjo-daro era. Okay, 4:2:1, they have maintained the measurement of the brick, and this is how length, breadth, height. Okay, cuboid shape bricks they were using, proper well planned city they were having. Okay, the drainage system they were having, proper streets they were having, parallel roads they were having. Everything was there in Harappa and Mohenjo-daro era. You must have seen the picture, and if you have not seen the picture, you have learned in history, right?
Yes, ma'am.
Okay, so by that time, so much of thing has been, okay, organized properly. The mathematics, okay, proper mathematics they were using. Okay, you can see proper measurement shapes every time they were using, but all of a sudden a flood came, or what came, natural disaster, and everything vanished. Okay, in ancient eras they were also using Sri Yantram. If you have heard about it or not, this here so many triangles are there. Okay, so many
Ma'am,
triangles. uh,
ma'am, actually, I got notes that our teacher sent. Should I send that to you?
I'm coming to that part. We will be discussing this one, right?
Yeah.
Yeah, we are coming to that one. Okay, I would not take that much time, because these things may come in exam, in MCQ question. Okay, so that's why I'm quick I'm taking this all the part. Now you can see we are having Euclid has given us axiom, Euclid has given us postulate, Euclid has given us few definitions also. So this definition do come in exam, that a point is that which has dash. So you have to write a point is that which has no part. Okay, actually this definition is trying to tell us that point has no dimension. Okay, point doesn't have any dimension. When you are drawing, when you are making a point, it doesn't have any length, it doesn't have any breadth. Okay, that's why the definition, a point is that which has no part. That means no length, no breadth, no dimension. Making sense?
Yes, ma'am.
Next, a line is a breathless length. Okay, so when we are drawing a line, we have just length. Thickness is not there. Okay, here no thickness is there. That's why the definition says that a line has breathless length. It has just length. Okay, one dimension we are having. Dimension means measurement. Straight line has one dimension. Point has zero dimension or no dimension. We cannot measure a point. Okay, a line we can measure, but just length we can measure. Now the next part says that, the next definition says that the end of line are points. Okay, that means a line is made up of point only. Point, 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 point. So many point came together, collaborated together, and has given us a line. Getting it?
Yes, ma'am.
Okay, that's why the definition says that the end of line are point. See, end are also point, and the next a straight line with point on itself. That means the complete line is made up of point. End is also point, and completely it is made up of point. Making sense?
Yes, ma'am.
Now, a surface is that which has length and breadth. A surface is that which has breadth and width. A surface is that which has length. Okay, a surface is that which has length and breadth. Okay, we understand, we have seen the surface, rectangular surface, okay, square surface, and we understand that those have length and breadth. Okay, next, the edges of a surface are lines. So basically Euclid said that this surface is made up of lines. So many line collaborated together, came together, and we ended up getting a surface. Okay, now a plane surface is a surface which lie evenly with a straight line on itself. The same thing which I am talking about. Okay, the edges, that means the end point of the surface, are line, and the surface is made up of line. So you can remember it this way. Okay, I am giving you a real life example. You must have heard about cotton seeds, right?
Yes, ma'am.
Okay, so at first we are having cotton seeds which we can relate with points. Now this cotton seeds just gone in the factory and has taken the shape of thread. Okay, which we can relate with the line. So point, so many point collaborated together and given us a line. Similarly, cotton seed converted to thread. Now this thread converted to a sheet. Now you must have seen that we buy the bunches of wool from the market, and we start making sewing the sweater out of that, right?
Yes, ma'am.
So yesterday I have seen that like one of the member, like, or one of my aunt was having thread, the roll of thread in her hand, the that wool. And today I have seen that she is having a she created a surface out of that. Is it making sense?
Yeah.
Okay, so so many lines attached together as has given us a surface. Okay, so zero dimension, first we were having point converted to one dimension, that means line. Now line collaborated together, converted to two dimension, that means surface. Now today I have seen a surface she is having. Now she is talking about she will make it a cap out of that. Okay, a cap she will make. So this two dimension she is going to convert into three dimension shape. Are you getting it?
Yes, ma'am.
Okay, so this is what is happening in Euclid's geometry also. Zero dimension collaborated together, converted to one dimension, that means line. Point converted to line, line converted to surface, surface converted to 3D solids. Clear?
Yes, ma'am.
Okay, so just read the statement carefully whenever a true false question or MCQ question is there from this part. Read it carefully. That a point is that which has dash, no part. A line is a dash length, breathless length, no breath is there. You need to learn it a bit. So far, we as a maths teacher say that please don't learn mathematics. But here I am telling you, you need to learn it a bit. Okay, you need to learn the definitions. Understanding is required and learning is also required. Got it?
Yes, ma'am.
So those are definitions. Those are few definitions which you need to learn so that you can answer your fill in the blanks question and true false question. Now here we are having Euclid's axioms. Universal truth. Axiom means universal truth. That means That means the way we are saying sun rises in the east, and we don't need to prove it. This is universal truth. Whoever want to see, they can just wake up in the morning and they can see that, yeah, it is rising in the east. Okay, so this is same way, these axioms are universal truth. We don't have to prove it, just we need to understand it. Okay, and you need to learn, Apurva, these axioms as it is, one by one. You will be learning like this. Axiom number 1 says things which are equal to the same thing are equal to one another. Axiom number 2 says if equal are added to equal, the whole are equal. Axiom number 3 says if equal are subtracted from equal, the remainders are equal. Axiom number 4 says if equal are added to equal, the remainders are equal to one another. Axiom number 5 says the whole is greater than the part. This way you need to learn each and every part from here. Making sense?
Yes, ma'am.
Okay, so let's understand what exactly our axioms is. The things over here, whatever statement you can see on the screen, these are really 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 basic. Okay, let's see. So the first axiom says that things which are equal to the same thing are equal to one another. See, these, we will be relating all these things. Just a moment, no. Yeah, let's continue. So here, each and every statement, you will find that it is quite obvious. And why you will find it is obvious? Because at first you have learned the practical. Practically, you have used these things. And that's why now you are learning the theory. Okay. So things which are equal to the same thing are equal to one another. In mathematics, we often, like, suppose x value is 2. Okay. And y is also 2. Things which are equal to the same thing, x is 2 and y is also 2, so we can declare that x is equals to y, right?
Yes, ma'am.
Okay, so this much understanding you are having, you have learned, practically you have used this thing from the very beginning. Okay, next, it says that if equal are added to equal, the whole are equal. Okay, suppose you are having x is equals to 25, or maybe you are having that x plus 23 is equals to 35. Now this is a equation, this is an equation. If you are adding, it's like seesaw. Okay, its equilibrium is maintained. If you are adding 2 kg over here, you have to add 2 kg over here, so that your equilibrium does not get disturbed. Okay, same way, when we are having equation, if I want to add 2 on the left side, I am bound to add the same 2 on the right side, so that the equality sign will be valid. Okay, equilibrium is maintained. Okay, are you getting it, Apurva?
Yes, ma'am.
Equal are added, already x plus 23 was equal with 35, already these two were equal. Now some of the student just tell me that no, these two are not equal. X plus 23 doesn't look same as a 35. So I'm not talking about the look, I'm talking about equality sign. These two are equal, right, Apurva?
Yeah.
right? Okay, these two are
Yes.
equal, and if you are adding the same on the left side and the same on the right side, the whole, again, whatever you will be getting as a whole in the left side and whatever you'll be getting the whole on the right side, again these two will be equal with each other. So if equal are added to the equal, the whole are equal. You have already learned the practical, now you are learning the theory. That's why you are finding this chapter not making any sense, but it is making sense. From here only everything came, the equation which you are solving now in mathematics, everything, okay, the like concepts which we are using the concepts given by our mathematicians only and Euclid only. Okay, let's move. If equal are subtracted from equal, the remainder are equal. You are getting it. Instead of adding, if I will subtract 2 from here and subtract 2 from here, whatever we will be getting, the remainder, the remaining thing over here and the remaining thing over here will be equal with each other, right, Apurva?
Yeah.
Okay, so you have to learn it as it is. State the axiom number 1 is this, axiom number 2 is this, axiom number 3 is this, axiom number 4 says things which coincide with one another are equal to one another. Can you see the my palm over here?
Yeah.
Can you see another palm?
Mm.
I'm just going to place it one on the other, one on the other. Okay, and both are covering each other completely, right?
Yeah.
Okay, so in mathematics, we are going to say things which coincide. That means just covering each other completely or lying on each other completely. Okay, this is called coinciding. That means lying on each other completely. Things which coincide with each other are equal to each other. Okay, just give me a moment now. So things which coincide with each other are equal to one another. We can say, okay, the shape of this palm and the shape of this palm is exactly same, are equal to one another, right, Apurva?
Yes, ma'am.
Okay, if you are having a straight line AB and if you are having a straight line CD and you are taking CD and placing it on AB and both are covering each other completely. So in mathematics, you will say AB and CD are coinciding with each other. Okay, hence AB is and CD are same. Got it?
Yeah, ma'am. Yes.
Learn it as it is. Okay, if the meaning is clear, if the understanding you are having, then learn it now. Now the learning, you have to learn it. Next, the whole is greater than the part, of course. Okay, the whole is greater than the part, you understand. You will be having one complete the whole pizza. Okay, and from somewhere I have got just a slice of the same size pizza. So I'm having a part, you are having a whole, so whole is bigger than the part, right?
Yes, ma'am.
Okay, next one says that things which are double of the same thing are equal to one another. Again, things which are double of the same thing, if x just a second. If x is 2k, okay, double of k, okay, if x is double of k, 2k, and y is also double of k, okay, then both are equal with each other. Just a moment. Yeah, if x is 2k and y is also double of k, then both are equal to each other, right, Apurva?
Yeah, ma'am.
Okay, and things which are half of the same thing are equal to one another. If x is the half of k and y is also the half of the k, then x and y are equal with each other, right?
Yes, ma'am.
Okay, so these are the axiom which we need to just understand and we need to learn. Now the next part is postulate. Now axiom and postulate are same thing. Axiom means universal truth, postulate means universal truth. Today whatever I am just saying, listen to me carefully, because these things you may get in exam. Okay, anything whatever I am just trying to explain over here, each and everything do come in exam. That means what is postulate, how postulate and axioms are different. So both means universal truth only. Axiom means universal truth, postulate means universal truth, but this postulate is specifically related to geometry. An axiom we can use anywhere in mathematics or anywhere. Getting it?
Yes, ma'am.
Okay, now we will be discussing postulates. In your NCRT, each and every axioms are given stepwise, number one, number two, number three, number four, number five, number six, like that. And postulate also, you need to learn it number by number. Number one postulate is this, number two postulate is this, number three postulate is this, like that. So number one postulate says that a straight line may be drawn from any one point to any other point. Okay, so suppose you are having one, like 2 points you are having. Okay, so when you will join this 2 point, you will be getting a straight line, right?
Yeah.
Okay, now there are so many ways to join these 2 points. Okay, I can also join it anyway, like this, but this is not a straight line. I can join it this way, but this is not a straight line. I can join it this way, but this is not a straight line. I can join given point. Okay, with two given point we can draw one straight line, right? One and only one straight line, right?
Yeah.
Okay, so this just understanding is required. Again, you need to learn this statement. This says the same thing. Given two distinct point, there is a unique line that passes through them. If we are having two given point, because you will be able to join this 2 point, because you will be able to join this 2 point, but just curves will not be a straight line, right?
Yeah.
Okay, let's move and let's see the next part. Two distinct line cannot have, I am coming to this one. A terminated line can be produced indefinitely. Okay, terminated means stopped. A line which is line segment. In lines and angles chapter, you have learned what is line segment, what is ray, right?
Yeah.
Okay, so this line segment we can call it terminated line. That means stopped line. Can be produced indefinitely. If we can produce it, we can extend it till infinity from both the direction. Okay, we can produce it from both the direction. And again, it may seem so simple and so, okay, yeah, we understand, but again I'm telling you, MCQ question will come, true false question will come. So like 5 marks question do not come from here. That may come from lines and angles chapter. 4 marks question may come from lines and angles, yeah. Or maybe here also we are having 4 5 question in NCRT, which every time just repeat itself. Okay, a circle can be drawn with any center and any radius. We can draw circle anywhere. Okay, with any radius and any center. I can draw a teeny tiny circle. I can draw a huge circle. I can draw circle with any radius. If the radius is 0.5 centimeter, I will be able to draw a circle. If the radius is 1 centimeter, I will be able to draw a circle out of it. Right?
Yeah.
Okay, now we will be doing this one. That proves that an equilateral triangle can be constructed on a given line segment. We have to prove it. Okay, so apart from learning all those definition, today after the class you will be sitting and you will be learning all those, for you will be learning all the axiom number 1 to 10. Axiom number 1 to 10. Telling anybody from your your parent or anybody. Okay, anybody, just ask them to just listen to you. The first axiom, second axiom, third axiom, fourth axiom, fifth axiom, like that. Similarly, first postulate, second postulate, third postulate, fourth postulate, fifth postulate, everything is given number by number in your NCRT. Okay, the way you learn any history or English, same way today you have to learn it. Okay, next, proof that an equilateral triangle can be constructed on a given line segment. So a given line segment, we are having a line segment which is given to us. Okay, AB. It is given already. Okay, and we have to show that on this line segment we can draw an equilateral triangle. We have to prove it. Okay, so first we will draw a line segment AB. You can draw it of 5 centimeter, 6 centimeter, 7 centimeter, your wish. Okay, you will be saying that AB is given already. Okay, given AB is equals to 6 centimeter, that you can say that given AB is equals to 6 centimeter. Now on this line segment, we are going to draw an equilateral triangle. So at first, we will be just keeping the needle of the compass at a needle, we will press at a point A. Okay, and we will take AB as a radius. Okay, in our compass, we will stretch it and we will take AB as a radius, and we will be able to draw a circle out of it like this. And here we will write that Euclid said that, okay, it.
Yes, ma'am.
Getting it, Apurva?
Yes, ma'am.
Okay, we are using the postulate. Randomly, we are not doing anything. We are using postulate. Okay, Euclid said that postulate number also you need to mention. That's why I'm saying learn it number by number. Now you will be pressing the needle of the compass at a point B, and you will be taking the same AB as a radius, and you will be making another circle like this. Clear so far?
Yes, ma'am.
Okay, now this is the point of intersection, this one. You are going to name it point P. Okay, once you will join A with P like this. Can you see this is the radius of the first circle?
Yeah.
And then you will be joining B with P. Can you see this is nothing but just the radius of the second circle?
Yeah.
Okay, and both, every time you have maintained the radius as a AB. So now can we say that this AP, AB, BP all will be same? It's an equilateral triangle.
Yeah.
Okay, only one reason you are giving according to Euclid's postulate. Please check the postulate number and write according to postulate number this. Okay, any circle can be drawn with any radius and any center, and hence we have drawn the circle from keeping the center as taking the center as a and radius AB, taking the center as a B and radius BA. Okay, two circles we have drawn, and we ended up getting an equilateral triangle on the given line segment. Clear?
Yes, ma'am.
Next we are going to take our NCRT. Can you say this example number 1, Apurva? Are you able to see the screen?
Yeah, ma'am.
Now here the question says that if A, B and C are 3 points on a line and B lies between A and C, then prove that AB plus BC is equals to AC. Okay, we have to show that AB plus BC is equals to AC, and every time whatever we will prove over here, we will use Euclid's axiom or Euclid's postulate. Okay, Euclid's axiom we will be using for proving that AB plus BC is equals to AC. So we will say that AB plus BC and AC is completely different. Okay, AB plus BC we are having an AC. Suppose we are thinking, let's understand first, then I'm telling you how to write it. AB plus BC you are having, and you are saying that AB plus BC and AC, these two are completely different thing. But you found that AB plus BC is coinciding with AC, yes or no?
Yeah, ma'am.
Okay, according to Euclid's postulate 4, things which coincide with each other are equal with each other, and hence AB plus BC is equals to AC. So we will write AB plus BC coincides with AC, and Euclid's axiom 4 says that things which coincide with each other are equal to each other, hence AB plus BC is equals to AC. From here only 4-5 questions are there, and you need to take it as it is. You have to practice this 4-5 question 2-3 times, and you have to write it as it is. If it is making sense to you, you are understanding it, you don't have to go that deeper and you need to try deeply that why we are doing so, what we are doing. No other understanding is required. If you are, just give me a moment. Yes. Okay, so we need to just take it as it is. Okay, just we'll be writing the axiom and we are done with proper reasoning we have given. Every time you are learning axiom so that you can give the reasoning wherever it is required. Okay, Apurva.
Yes, ma'am.
Example number 2 just now we did, right?
Yeah.
Okay, so example 1, example 2, we are done. This proof doesn't come in exam. Do you have this proof in your copy?
Yeah, I think so. Yeah.
Okay, two distinct lines have more than one point in common. Let's see what the theorem says. Okay, two distinct line. Distinct means different. Two different lines. We are having one of the line that is AB and another line that is CD. Okay, now let's try understanding. Two different lines we are having, and what we have to show over here cannot have more than one point in common. These two lines will not have more than one point in common. Maximum, when I will show you a straight line AB and a straight line CD, the chances are both will intersect each other, right?
Yeah.
Now we cannot say that it is intersecting, then again intersecting, then again intersecting. That we cannot say because it's a straight line. Okay, it doesn't works like a curve. It is not going to work like a curve that intersecting, again intersecting, it cannot happen, right?
Yeah.
Okay, so maximum, if it will intersect, then it will intersect at one and only one point, right? Agreeing with me?
Yeah.
Okay, and otherwise it will never ever intersect, right?
Yeah.
Okay, so that's what we need to explain in statement now. Let's see. we can write it as it is, the way here it says. Now you tell me whether it makes sense to you or not. Okay. uh Here we have, suppose two lines L and M. Rather than AB, you can take AB, you can take CD, okay, if you want, or otherwise you can take one of the line. You can, lines and angles chapter you have learned that we can represent. Okay, you have not learned because parallel line is still we have not discussed. Suppose we are calling one of the line as L and another we are calling as a M. Okay, and we need to prove that they have only one point in common. Okay, maximum if they have, okay, if they have any point in common, that maximum one point only they'll be having. More than one they won't be having. Okay, so the chances are one point of intersection will be there or no point of intersection will be there. Both the line are just going randomly in any direction. Okay, maybe both are parallel with each other. Getting it?
Yes, ma'am.
Okay, so we need to write the statement like this. Okay, let's suppose that the two line intersect at two distinct points. Suppose this L and M, we are using the contradiction method. Contradiction method means, contradiction method means whenever you must have seen the court scene in the movies. Court scene. Okay, whenever the culprit is there in front, so they start with the reasoning that okay, you have not done. Okay, you have not done and you was not there, you was not present at the crime scene, right? So they say yes, then they start giving question and question and question, and like by themselves only they admit that they were present at that time over there, right?
Yeah.
Okay, so contradiction method they apply. They say that okay, you have not done. Okay, you have not done. For proving that you have done, they say that okay, you have not done anything, right?
Yeah.
Okay, so here we are saying we want to prove that maximum one point in common, but we will start with the reasoning that okay, let's say 2 points are there in common. One of them is P, another is Q. So far, is it making sense?
Yes, ma'am.
Okay, next one. So we have two lines passing through the two distinct point P and Q. Okay, we are saying I'm coming to the another. Okay, let me wipe over here. Since we have to cover all this question, I'm taking it quite quick. So suppose we are having L and M, both are intersecting each other at 2 point. Okay, not 1 point, 2 point. Okay, so two line passing through two distinct point P and actually drawing it is not possible. Okay, we need to just write the statement. So are you understanding? If we are saying that suppose there is a point P which is lying on L and the point P lying on M as well. Similarly, point Q. Point Q is lying on L and this point Q is also lying on M. Q is lying on L and M and P is also lying on L and M. Getting it so far?
Yes, ma'am.
Okay. So what we are saying in previous one of the postulate we have discussed that through two given point, one and only one line we can draw. If two given point we are having, then one and only one straight line we can draw. And here are you understanding with P and Q we are saying that two line is passing, L also M also, L also M also. Getting it?
Yes, ma'am.
Okay, so this is just uh, this is making that axiom invalid. Okay, and due to that reason we are saying that two distinct line cannot have more than one point in common. You have to write the statement as it is. Suppose we are having in your language, suppose we are having two line L and M. Okay, Now let's assume, for now let's assume that two L and M has 2 point common, P and Q. That means with P we can draw two line LM, with Q we can draw two line LM. But Euclid's actually says that with two given point, one and only one line can be drawn. So two is straight line. Okay, we are not. This is completely contradicting. This is completely contradicting the fact that two distinct line has more than one point in common. Contradicting means this is making it false. Okay, that two lines have more than one point in common. Hence you will just copy paste the theorem. Got it?
Yes, ma'am.
Okay, or you can, rather than writing this all, you can say that this is making our assumption false. Hence two line have cannot have more than one point in common. Crystal clear, Apurva?
Yes, ma'am.
Okay, now you can see which of the following are true and false. This type of question do come in exam. Okay, where you just have to say true false, you will be able to do it, right?
Yeah, ma'am.
Next, give a definition for each of the following. Are there other term that need to be defined first? What are they? Parallel line, distance between two lines, okay, are always same, always same, always same, always same. That's the definition of parallel line, right?
Yeah.
Okay. Perpendicular line, angle between two lines. If it is 90 degree, we will be calling it perpendicular to each other, right?
Yes, ma'am.
Okay. Similarly, you will be able to define the line segment, radius of a circle. Radius of a circle from the center to any point on the circle. Any point on the circle. The distance from center to any point of the on the circle. Any point on the circle. Okay, I am showing you a circle. It's a circle. These are the points on the circle. These are the points inside the circle, and these here we will be having point outside the circle. Getting it?
Yes, ma'am.
Okay, so on the circle, the distance between any this from the center to the any point on the circle, if that is, that's called the radius, which will always be same, right?
Yeah.
And square is such a quadrilateral where length and breadth both are same. Okay, and each interior angle is 90 degree, right?
Yeah.
Okay, now let me check the proof based question. You will be able to do these questions. Question number 6, let's do first. AC is equals to BD, then prove that AB is equals to CD. We need to prove that AB and CD are same. See, AC and BD are same. Do you know how to do it, Apurva?
Kind of like.
AC and BD are same. And what we need to prove? AB. So we want to make this AC as a AB. So we will be subtracting BC from here, and the same BC we will be subtracting from there. And we will end up having the proof. AB is equals to CD. Please check it. Because Euclid only said in one of the axiom, equal subtracted from equal, the remainders are equal, right?
Yeah.
Okay. So we started with this given part that AC is equals to BD, equal, both side equal. And we are going to subtract same from both side, BC, BC. Then the remainder, that means AB and BD, CD will be equal. Yes or no? You check the figure, then only you will understand. AC minus BC. Okay, AC minus BC, can we say this is AB?
Yeah.
Apurva. Okay, and the other side, BD minus BC. BD minus BC. Okay, BD minus BC. Can we say it is CD?
Yeah.
Okay, so we are using just the axiom every time in each and every proof. We just have to use the axiom. Proper reasoning we will give, we will get the marks. If reasoning, axiom number, and axiom statement we will not mention, we will not get the marks. Got it?
Yes, ma'am.
Okay, question number 4. In question 4. Yeah, question number 4. If point C lies between 2 point A and B such that C is lying between A and B such that AC is equals to BC. See, it is given already. It is given already that AC is equals to half of AB. We need to show that AC is equals to half of AB. Okay. So if AC is equals to BC, can I add AC on both sides? AC plus AC?
Yes, ma'am.
Because Euclid only said equal added with equal, the whole are equal. Okay, so we are having 2 AC over here, and we are having BC plus AC. Okay, BC plus AC is AB over here. Okay, which we can say AC is half of AB. See, we want to prove. The proof is really simple. Logically, we understand the proof also, but we are trying to go by using the axiom. One step we are writing, axiom we are writing. Another step, okay, axiom is supporting our each and every step. Making sense?
Yes, ma'am.
Okay, so always think about which axiom you can use, which axiom, which number axiom, which statement will support whatever you are writing. Okay, otherwise this type of thing we do very often in mathematics without reason giving any reasoning, right?
Yeah.
Okay, but here every time we'll be writing axiom. This chapter is quite different, and we have to handle it this way only. Okay, we will not think about making it more simple or more understanding. It is already easy. Okay, next, in question number 4, point C is called the midpoint of the line segment AB. Yeah, it is called the midpoint. Okay, if C is lying between A and B, that's what is written in question number 4. Prove that every line segment has one and only one midpoint. Now again we will start with contradiction method. We will say that suppose AB has two midpoint. Okay, that means C is also the midpoint and D is also the midpoint. Making sense?
Yes, ma'am.
Okay, if C is the midpoint, that means AC is equals to BC. And if D is the midpoint, that means AD is equals to BD. Right?
Yeah.
Okay, now we can say, just a moment, which reasoning we can give. AC and BC are same. AD and BD are same. We are getting understanding, we are having that C and D are the same point, right?
Yes, ma'am.
Okay, but we need to give proper reasoning. After writing this one, we will write AC plus BC is equals to AB, right?
Yeah.
And we will write AD plus BD is equals to AB, right?
Yeah.
Now we can compare this one with this one. Things which are equal to same thing are equal to one another, right?
Yeah.
Okay, so we can say that AC plus BC is equals to AD plus BD. One of the axiom we have already written. After this step, we have written the axiom. Things which are equal to same thing are equal to one another. Axiom number also you need to mention. Now here we have already written AC and BC are same. So both of them I can write AC plus AC. That means 2AC, right, Apurva?
Yes, ma'am.
And AD plus BD I can write as a AD plus AD. Okay, that means 2AD.
Yeah.
Getting it? Now we can say AC and AD are same. Okay, so only one midpoint can be there. Making sense?
Yes, ma'am.
Okay, so we understand it is making sense already, but we are just moving this, then this, then this. Again, for now, what I would suggest, practice. Okay, practice it. If you have understood, then practice it enough so that you will be writing the same step in your exam. Getting it?
Yeah. Okay.
So we are done with 4, 5. We are done with 6. I am taking the 7 one. In your school, do they have done 7 number?
Actually, like she just gave some questions, outside questions.
Okay. So when you are having your exam?
On Wednesday. This one.
Okay. So please inform our team. So if you want to discuss those outside questions, okay, we can have a discussion from there. Okay.
Okay.
Okay, Apurva. So for now, I am keeping this much over here. Okay, because if you have got some set of questions from your school, okay, you need to focus more on that because that may come in exam. And yeah, on this one as well because NCRT first. Okay.
Yeah.
So yeah, please inform our team that one more class is needed. I am also going to inform. How many questions are there? First, tell me.
There's only there's like five questions.
Okay, only 5 questions we are having. So yeah,
Yeah.
please inform our team and send the notes beforehand so that I can see the discussion. Okay, if it is required or you will be like you will be able to do by yourself or you need explanation of the same.
Hmm. I'll be able to do it by myself, I think. She has
You
written the explanation, so
okay, you check it today